mga ka-Johnny! Welcome back to my YouTube channel. This is Sir Raubensun and today we are going to discuss limit at infinity part 3. But before I begin my discussion in this video, do not forget to click the subscribe button and give me a thumbs up if you like my video, okay? Okay, in this video, I'll give you lots of examples for you to practice all the rules that I have discussed in my previous video, okay? So let's begin. Example number 1. What if you are asked to get the limitation of 5 all over x fifth as x approaches to positive infinite? What is the limitation for example number 1? I'll give you 5 seconds to think. Very good. What is the answer? The answer is, that is 0. The limitation of this function is 0. Why? Simply because your numerator here is a constant, that is 5. For our rules that I've discussed in my previous video, once your numerator is plainly constant and your denominator is any function, as your x approaches to either positive or negative infinite, automatically the limit of that function is 0. That's great. Good job. Continue that performance. Let's proceed to example number 2. What if the function looks like this? The limitation of 3x raised to 5 as x approaches to negative infinite. How are you going to evaluate this function? I'll give you 5 seconds to think. Okay, what is the limit of this function? I can't hear you. What is the limit of this function? Very good. The limit of this function is negative infinite. Why? As you can observe, our function is a plane of only one term function, okay? And your exponent here is 5, and your x approaches to negative infinite. We all know once a negative infinite put inside a variable, this exponent is odd, that is, the answer is negative infinite. And the negative infinite multiplied to any positive constant, that is negative infinite. Because negative multiplied to positive, that is negative infinite. That's great. Continue that performance. Let's proceed to example number 3. What if the function looks like this? As x approaches to negative infinite. My function now here for example number 3 is 5 all over x squared plus 2 as x approaches to negative infinite. I'll give you 5 seconds to think. Okay, time is up. What is your answer? I can't hear you. What is your answer? Very good. The limit of this function is equal to 0. Why? Simply because, as you can observe, example number 1 and example number 2 are the same, meaning your numerator here is plainly constant and your denominator is any function. Again and again, for our rule, once your numerator is a constant and your denominator is any function, as your x approaches to either positive or negative infinite, automatically the limit of that function is 0. Again, no hesitation, the limit of the function is 0. Okay, you're doing a great job. Let's continue this example for limit at infinity. We are down to example number 4. What if your function looks like this? The limitation of negative 4x raised to 10 as x approaches to positive infinite. Okay, for our example number 4, what if your limitation of negative 4x raised to 10 as x approaches to positive infinite? Okay, for our example number 4, I'll give you 5 seconds to think. Okay, time is up. What is your answer for example number 4? That's good. That is negative infinite. You're doing a great job. That is negative infinite. Why? Simply because, as you can observe, your function is negative 4x raised to 10, and your function approaches to positive infinite. We all know that a positive infinite put inside a variable whose exponent is even. Again, even. Always remember the result is still positive. And we all know, and as you can observe, beside your variable x, you have a negative constant and a positive infinite multiplied to any negative constant. The result is negative infinite. You're doing a great job. Continue discussing the examples for limit at infinity. We are down to example number 5. For example number 5, what if your limit or the function or the limit of the function looks like this? The limitation of x squared minus 3x cubed minus 5x4 all over 3x squared plus 4x raised to 5 as x approaches to negative infinite. What is the limit of this function? So your function here is a polynomial function or a rational function, consists of f of x and g of x, and those are polynomial function, and your x here approaches to negative infinite. What is the limit of that function? Again and again, in solving this kind of problem, you have to identify what is the leading coefficient. Again, leading coefficient is a term that consists of the highest power among other terms. Let's identify the highest degree or the leading coefficient for our numerator. Our numerator, the highest degree is 4. So meaning, since the highest degree is 4, automatically, this is our leading coefficient. Again, not all the times that the leading coefficient is written at the first part of your polynomials. There may be times that it is written on the middle or at the end of your term. For as long as it consists the highest power, automatically, that is your leading coefficient. So this is the leading coefficient. And now for the denominator, what is the leading coefficient? Okay, very good. The leading coefficient is 4x fifth because it consists the highest power among other terms in the denominator. After locating or identifying the leading coefficient, you have to compare the degrees. Okay, so after we identify this one, could you please identify what is the limit of this function by a mere inspection? Okay, that's great. I'll give you 5 seconds to give the final answer for example number 5. Okay, very good. What is the answer? The answer is, that is 0. That's great. The limit of this function is 0. Why? Simply because after identifying your leading coefficient, you have to compare which one is greater and which one is the smaller one. So as you can observe, denominator here is greater than your numerator by looking at your degree or exponent. 5 is greater than 4. Automatically, denominator is greater than numerator. Once the denominator is greater than the numerator, automatically, the limit of that function is 0. No hesitation, the limit of that function is 0. Okay, that's great. You are doing a great job. So now let's keep practicing. So now let's proceed to example number 6. What if your function looks like this? The limitation of x squared minus 3x cubed plus x all over x cubed or 2x cubed plus x squared plus 2. So the J. Okay, so what if your function looks like this? The limitation of x squared minus 3x cubed plus x all over 2x cubed plus x squared plus 2 as your x approaches to positive infinite. Okay, I'll give you 5 seconds to give the answer. Okay, time is up. What is the answer for this problem? Very good. The answer for this problem is negative 3 over 2, or the limit of this function is negative 3 over 2. Why? So what are you going to do is to, again and again, if you encounter this kind of problem, you have to identify the leading coefficient of your numerator and denominator. For the numerator, what is the leading coefficient? Very good. The leading coefficient is negative 3x cubed because negative 3x cubed consists of the highest power among other terms in the numerator. For the denominator, what is the highest power? Very good. The highest power or the leading coefficient is 2x cubed. Again and again, the leading coefficient is not always written at the beginning of the polynomial or the beginning of the function. There may be times that it is written on the middle and at the end of the function, okay? So since, as you can observe, you already found out who are the leading coefficient both in numerator and denominator. After that one, you have to compare the degrees of these leading coefficients. The leading coefficient or the degree of the leading coefficient of your numerator is 3. Na airplane ni Agi, no? Again, after identifying the leading coefficient of numerator and denominator, you have to compare the degrees. For our numerator, the degree is 3. And for the denominator, the degree is also 3. And obviously, that is the degree of numerator is equal to the degree of denominator. What are you going to do if the degrees of the leading coefficients are equal? Yes, that's great. What you're going to do is to simply get the numerical coefficient of your leading coefficient. What is the numerical coefficient of the leading coefficient for in the numerator? Obviously, that is negative 3. You write negative 3 for the numerator. What is the numerical coefficient of the leading coefficient in the denominator? That is 2, and you write that one here. Okay. So obviously, the limit of the function is negative 3 over 2. That it sounds very easy. That's great. You're doing a great job. Okay, we're down to example number 7. Okay, lots of example in this video, so let's proceed to example number 7. What if your function looks like this? The limitation of 3x4 minus 5x5 minus x all over 2x minus 1 as x approaches to negative infinite. Okay, what will happen if your function looks like this? Same thing that we did in our example number 5 and number 6. You have to identify the leading coefficient. Okay, I'll give you 5 seconds to find the result. Okay, time is up. What is your answer in this example? I can hear you. Okay, very good. The answer is negative infinite. How? How did we get that negative infinite as fast as that? Okay, same thing. You have to locate which one is your leading coefficient. Which is the leading coefficient in your numerator? Okay, very good. That is negative 5x5 because x5 is the highest degree among other terms in the numerator. For a denominator, what is the highest degree or the leading coefficient? Obviously, that is 2x. And after you find your leading coefficient, you have to compare the degree. And obviously, numerator, which is 5, is greater than denominator. What are you going to do? After you compare that numerator is greater than denominator, this is the best way to do. You cancel other term that is not the leading coefficient and you copy the leading coefficient. It will become the limitation of the leading coefficient for numerator is 5x5 all over 2x as x approaches to negative infinite. So after that one, as you simplify that one, we all know that 5, we can still divide this one by canceling 1x to our denominators. It will become the limitation of negative 5x4 all over 2 as x approaches to negative infinite. How did we come up with negative infinite? This is what are you going to do? This is now the final term as you simplify your remaining leading coefficient. Okay, so you all know that your variable here is x and that is being raised to 4 and your x approaches to negative infinite. Negative infinite put inside a variable whose exponent is even, meaning it will become positive. What is our variable exponent here? That is 4. Negative infinite times negative, positive. Positive multiplied to negative, negative. Negative multiplied to positive, that is positive. Very good. And you all know obviously that your variable here is beside to a constant which is negative, and a positive divided by 2, multiply to a negative number, that is negative infinite. So that's how fast you can able to answer that one by a mere inspection. So this is example number 7. Thank you so much for watching this video. If you like this video, do not forget to click the subscribe button and give me a thumbs up if my video helps you. Okay? So see you in my next video. Bye-bye!